All right, here we are in our fourth installment of streams and surface processes. All right, so in the last one, we talked about longitudinal profiles. Here we're looking at one over time. So, steep mountainous areas over time can erode and become gentle, flat areas. So, we're looking at up here a more mountainous area where we have a narrow V-shaped valley. So here the flow would be fast because it's, got a steeper gradient and gravity's carrying that water downhill. Over time, that landscape is eroded by all the sediment that's carried by the water in the stream, and we start to get a meander that looks like this. And then over more time, that meander continues to grow. We might get some oxbow lakes, where the river kind of creates a new course. And then we develop a really flat and broad area that we call a floodplain. And floodplains are important because this is area where we have a lot of development. So if you look at agriculture over time, the central U.S. lies in the floodplain, right? So we have a lot of farms and cities and rural areas across our country that reside within these floodplains. So we definitely need to be concerned with those. I'm going to scoot down here because floodplains are areas where if there's even a little increase in precipitation, you generally get landscapes that are saturated with water. And where's the water going to go? If it's flat, it's going to crest the banks and it's going to flood the floodplain. Not only is it flooding with water, but it's also depositing in a lot of sediment. So when rivers flow downstream and eventually slow because of the lack of the gradient, they're going to deposit sediments. And this generally happens at the mouth of the stream, but it can also happen when streams flood. So deltas, like the Mississippi River Delta, are an example of where you get a lot of deposition of sediment. And what that looks like is you have all these streams or tributaries that are entering the Gulf. And as they enter the Gulf, their velocity is slowing. And as the velocity slows, the sediment that the stream is carrying is deposited. And so you get this network of sandy deposits that form a fan. It's called an alluvial fan. And so this is what the Mississippi Delta looks like. And the Mississippi Delta is important because there are cities and there are coastal towns that reside within this delta. And so obviously this is not only at sea level, but it's made of a lot of sediment deposits that during times of heavy rainfall or flooding or hurricane season can be inundated with water, which creates a tremendous amount of flooding, which is a crazy natural disaster along the Mississippi. So the Mississippi has a huge delta that's been forming over the last 500 years. What the Civil Corps or Army Corps of Civil Engineers did in the late 1800s, early 1900s, is they engineered structures to help mitigate flooding along the Mississippi River Delta. Unfortunately, these structures have not withstood the effects of time. So here is kind of an image. It's a map that shows where the Mississippi Delta was and where it's grown. So currently the delta is all the way out here. And these are actually roads, guys, that lead to different areas in the Mississippi River Delta. No, they're not. They're rivers. What am I saying? But there are roads. There are areas here that are developed, like New Orleans is right there. Come on, crazy lady. And obviously, if New Orleans lies on the Mississippi River Delta, right here, and this area is prone to flooding, we need to be especially concerned about infrastructure and how to prevent flooding. And so, what do? We build levees, and levees are just raised, you can think of them like ridges adjacent to the river channel. And what they do is they heighten the channel banks, basically. So during heavy rainfall, as the water in the river tries to crest above the floodplain, these ridges prevent flow into the floodplain. So anyway, they work great until they don't work. Here's an example. So during a flooding event with a natural system, here is where your surface is. The water table rises, and then obviously the water crests the banks of the river and it floods everything that's low relative to it. So that would be the floodplain, right? Natural levees are sediment deposits that create little ridges that prevent some of that flooding. Unnatural levees are human-made, and they're built to even higher levels to prevent flooding, right? So what is a flood? A flood occurs when the stream itself is at capacity. So in other words, it cannot hold any more water, and therefore it will crest the banks and flow into the floodplain. So this happens on a regional scale. In recent years, we've had a lot of flooding in the central United States. It can happen out west in areas that are typically dry when you have a heavy rainfall and the ground just can't, it gets saturated quickly, and it creates basically a flood of water running across the ground. It can happen during winter when we have ice that blocks the flow of a typical river system. And flooding by far and away in the United States is what causes the greatest amount of economic distress. So seasonal floods, typically in the spring. Here's one in 2011, flooding along the Mississippi River. Again, Mississippi River, because the floodplain is so wide, as soon as it crests, it's going to flood a huge area. And the more it crests, the more it floods, right? So floods are crazy. Here's a flash flood in Vermont that happened, washed out a road. Yikes. Some ice jam floods. I don't know if I have pictures. I don't have pictures of those. Typically happen in areas where obviously it's colder. You get those sometimes along Lake Erie when it freezes in the winter. And then dam failure floods, that's not good. You don't want that happening. There was actually one in Ohio that was a result of a dam failure. So anyway, yeah, I think that kind of encapsulates all of what I wanted to talk about, except for pollution of freshwater systems, particularly surface water. And we'll address that on Friday during our Google Meets Real World Curriculum Connection from 2 to 3. So that wraps it up. Hopefully you enjoyed my lectures on stream flow and processes and dams. Dams. All right, peace out.